We can optimize the previous code by removing a couple of instructions. For example, we use a temporal registered $91 to keep the intermediate result. And also in the end we copy the content of this register into the $sign with 0 in order to return it back to the main program. So you can replace $sign T1 by the V0 in the beginning. So as you can see here, we use the $sign V0 or the desired or target register and we keep the result inside this one from the beginning. So we don't need this line and this line replaced by this one. Also, the input argument is inside the sign A0. We copy it inside the another temporal register, but we can use that value. You don't need to copy it here. So as you can see, any place that I have T1, I replace it by a 0. So by this way, this line is also can be removed. So this is the optimized code. Another problem that I mentioned in the previous video is that we use in the main program, we use $91 to restore the return value of the first bacterial. But here, as you can see, we use T1 inside the factorial function. So this results will be overwrite by the next time that I call factorial function here is called the factorial function for the second time, and this T1 register will be overwrite by this value. Therefore, the result of the first factorial that I saved inside the T1 will be overwrite here. So we should solve this problem. Also, since the CPU has a limited number of registers and these registers are commonly used by all the functions and the main program, it is possible to override the value of the register by some of the other ones. In order to prevent this problem, we can keep important registers from being overwritten by a function card by saving them before the function executes and restoring them after the function completes. So in the beginning of the function, we should save their function, the important registers. And before we return back to the main program or the color program, we can restore them back. But there are two important questions now. Who is responsible for saving registers, the color or the color, and what exactly are the important register and where should we save them in order to solve this problem? They divided into two sections. The color knows which registers are important to it and should be saved for before we call the function, and the color, we also know exactly which register it will be used and potentially override. When we use a function that is provided by a third party or some other programmer can be considered as a black box. So you don't know which registers are used inside the function, responsible for saving important registers across function calls. The color only knows which register are important to it and which one should be saved. Before we call the function, and the curly or the function knows exactly which register it will be used by its body and potentially be override. But there is a problem here that in black box programming approach, the color and color do not know anything about each other's implementation. We can download the function from a third party or another programmer, and we want to use it, so we don't know how they implement this function and which registers are used inside the implementation of this function. So a function should be able to interface with any client, and different implementation of the same function should be exchangeable. So how can two function, cooperate and share register when they don't know anything about each other? MIPS uses conventions to split the registers between the callee and the color. So callee is responsible for some of the registers and it should be saved by the callee before it changed. And the color is also responsible for some other parts. The color is responsible for saving and restoring any of the following. Register. Register $930398083. And register with 0 and register $V1. So all of this register can freely modify by any functions because the callee knows that they are saved by the color. So the function can easily and freely change this register and it is the responsibility of the color to save this register. If they are important for the color and the color is responsible for saving and restoring any of the following registers, register as 0 till 7 and register R a return address. So these are the registers that we should save them inside a function if we need to use them. If we want to overwrite these values, the value of these registers, we have to first save the initial value of these registers. And before we return back to the color, we should restore the initial value of them. So the color may assume these registers are not changed by the color. So we expect that the content of the 0 till 7 are the same after we call a function. But if you want to call a function and you save some value inside T0, for example, you have to save it in some place. Then call the function and after call the function you should restore the content of the T0 from the position that you save it. In the previous factorial example, the main or the color should save two registers, register $91 and register a $sign or return address. Key 1 should be saved because the factorial function use it here and overwrite the value of register a 0 on this register. And register your return address or A, as you know, will be implicitly overwritten by the jump and link instruction. So in order to return to the real return address before we run this program, first of all, we have to save the return address, the main program or the color. And then before we return here, we restore the return address or for the $sign. T1 since this jump and link for the second time that we call the factorial will destroy the content of this register. I have to save it somewhere, and after I call this function, I have to restore it. But the curly or the factorial function does not need to save anything because it's only write to register T0, T1, and V0. And these are not the registers that should be saved by callee. Callee is responsible for 07 and on the return address. None of them are changed by factorial function. Where should we save this? The content of these registers.